Alright guys, so today we're going to talk about logarithms. These are specific function operations that allow us to measure things like earthquakes, the sound levels, so decibels, and brightness of stars. Ooh. So I'm going to type this first little doohickey up right here. The above phrase is how we denote logarithms, and it's a specific way of talking about them, and I wanted to type that up for you so you knew how to say it correctly. And I need so this says log of x equals A. That's how you pronounce that first part. And that is equivalent, which means it's vice versa, goes both ways, to 10 to the A is equal to x. So the logarithm of any number is essentially 10 to that value. So, in my calculator, I'm going to go ahead and find the log of 6.3. So, log is a button that is right next to the number 7. So you just hit that log button, 6.3. And you get about 18 notes. Not yellow. So 0.799, or about 0.8. And since these functions go back and forth, it's like saying 10 to 0.77, excuse me, 799. I'm going to go see if that'll give me my 6.3. So my calculator, I'm going to hit 10, the up arrow under clear, and 0.799. Hey, I basically get 6.3. If I did 10 to the 0.8, I get a little over 6.3. But it's essentially 6.3. So logarithms and the 10 to that exponent is what gives me it. And this, because there's no necessarily base here, is like saying 10 log base 10, because it's an invisible 10. The one below it, however, is read as log, ooh, not what I wanted, sorry about that. Log base b of x is equal to a. So that's how you read the left part. Where x is equal to b to the a power. So they go back and forth. So for the next example, we're looking for what that could be. So my base is 5, because the 5 is the little guy that he is, a little subscript. What? Let's try that one more time. So 5 is my base, because that's the little subscript. To the x power is equal to the big 25. Well, what power does that have to be? What does x have to be? In this case, x is 2. So what we're going to do in this next one is we are just going to write it in exponential form. So we're not solving, we're not simplifying, we're just writing it. So the base is the smaller number, or the subscript, so in this case 4. The exponent is the equal part, so 4 squared is equal to 16, which is a logical statement. 4 to the third is equal to 64. 6 to the negative 2 is equal to 1 over 36. Which is it? Well, remember, we don't like negative exponents. To make them positive, we go ahead and put them in the denominator. So it's like saying 1 over 6 squared, and hey, what is 6 squared? It's 36, which is exactly what we have above. This guy, again, since he has an invisible base, the base here is 10. So it's 10 cubed, which is equal to 1,000. is that? Huh. Didn't know what that was. Alrighty. We're going to go ahead and try and find these without using a calculator. So 7 to what power is equal to 49? Good. 2. 2 to what power is equal to 16? Well, 2 times 2 is 4. So I've used it twice. Times 2 more is 8. 8 times 2 more is 16. So how many times did I multiply 2 together? 4. And then we have 2 to something is going to give me a 1 over 8. Well, since it's a fraction, that has to be some negative value, right? It only makes sense for that to be a negative value because I have my fraction there. Okay, well, we just said 2 to the 4th was 16. What's 2 to the 3rd? Good. So my x here is a negative 3. Alright, so we're going to go ahead and find each value of my x. So I have my base of 5 to the exponent of 2 is going to be 25. Good. This one time my base is x, so the 3rd is 64. So I want to undo that by taking, not the square root, but the cube root, because it's the 3rd power. And we know how to do that in our calculators. And when I take the calculator of the cube root of 64, what do I get? Excellent, 4. Try these next two. I want to see what you guys come up with. Hope we got 36 and 11. Alright, so the inverses of e and natural log. So the natural log is the opposite of that magical e value that we talked about yesterday with the compound interest. And 10 to the a, we already talked about, is the opposite of logarithms. So when I'm trying to find x, if I do not see the letter e, I'm going to take the log of both sides. And when I take the log of both sides, the 10 and the log cancel out. So I'm left with x is equal to log of 75. Which when I type that in my calculator, I get 1.88. Good. Oppositely, when I see the e, to undo e, I'm going to take the natural log of both sides. The natural log and the e cancel out, so I'm left with x is equal to the natural log of 75. And that is going to give me 4.32. Alrighty, so we're going to go ahead and just write it again in exponential form. So just rewriting it. So since I'm dealing with ln, my inverse is going to be e. So e to the 2.1 is about 8. E to the 3.9 is about 50. And these aren't exact numbers, so because they're not exact, we need the about. E to the 1.6 is about 5. And e to the negative 1.6 is about 0.2. Alright, we're almost done. We're going to go ahead and find the values of x here. So since I'm dealing with ln, I'm going to take the e to both sides. E and ln cancel out, so I'm left with x is equal to e to the 10. And I can go ahead and just plug that in my calculator and get a really big number. 22026.47. Again, I see ln, so I'm going to do e. So I'm left with x is equal to e squared, which is 7.39. Do these last two, and yes, you're going to get a big number for this third one. And okay, that's all I got for you.